Hello, my name is Scott Medjian, and today I'll be going over problem 40 for week 9. Prove that the coefficient of performance of a Carnot refrigerator is K Carnot equals Tc over Th minus Tc. So the first thing I've included is an image from the Mastering Physics page, but this image is a little, the main reason I included this is because um, Tanito suggested that we use the Mastering Physics homework to help us in this explainer video, but there are a lot of misconceptions that can happen when you're going off of this, so I'll do my best to explain those now. So the first thing to take note of is that uh, we are doing a refrigerator example, and they give us um, a heat engine basically. So for example, if we start at point D and we go to point C, instead of being an isothermal compression, that would actually be an expansion. So all of these expansion compressions are mixed up for the example we're doing. So please keep that in mind. So every time it says compression, it really should be expansion, and every time it says expansion, it really should be compression. The other thing is because those are switched, the TC and TH need to be flopped or flipped. Um, yeah. And then I have these arrows pointing in the direction a refrigerator goes, which is counterclockwise. Okay, now we can actually get into the problem, and that part is a little easier. So remember, we want to show that K Carnot is equal to Tc over Th minus Tc. In the general form, we know that K is equal to Qc over the work in. Um, for getting QC, that's pretty easy, since we know that in adiabatic processes, Q is equal to 0, and in isothermal processes, Q is just equal to Ws. And since uh, the only time we're really doing uh, work in the isothermal is when we're changing this Tc temperature, we just um, we can substitute in QC is actually just TC, right? So that's the first part. Now we want to solve for the work in. Um, so on the um, what's it called? The mastering physics, we already have shown that work is equal to QH minus QC. So if we use that, then just write um, QH minus QC. Well, we already figured out that QC is equal to TC, so now we just need to find out what QH is. And, um, well, if we do that, the same thing happens. We have a 0 plus a work, and the work we're getting is basically um, just the temperature change. So that ends up also being QH equals TH. So it's very similar. Um, and then if you just substitute in the work here and the Q's, you basically solve it. Yeah. So I'll write that out, I guess. So K Carnot is equal to so substituting in QC for TC, substituting in work for QH and QC, and then subbing those in for T's, we just get that TH TC. Yeah, so kind of simple. The hard part is deciphering the graph. Yeah, hope that helps. Have a nice day.